In this lesson, you will learn how to prove trigonometric identities. Last time, you learned that tan x is equal to sine x over cos x. We refer to this equation as a trigonometric identity. This identity can be represented in these two other forms. Let's take a moment to review why this identity is true. We start by considering sine x over cos x. We can then substitute opposite over hypotenuse for sine x and adjacent over hypotenuse for cosine of x. This stacked fraction can be rearranged as follows, and the hypotenuse cancels, leaving opposite over adjacent, which is equal to tan of x. You also learned that cos squared x plus sine squared x is equal to 1. Again, this identity can be written in these two other forms. All of the identities can be summarized as follows. It is important to be able to recognize an expression that is part of one of these identities. For example, if you see the expression 1 minus cos squared x, consider that it is equal to sine squared x, as per the summary slide. For the quotient identity, it might be helpful to think of a pyramid where sine x is at the top. It can then be seen that tan x is equal to sine x over cos x. For the Pythagorean identity, by placing 1 on the top of the pyramid, we can easily conceptualize it as being the sum of sine squared x and cos squared x. The learning objective for this lesson is to be able to perform the necessary substitution to prove a trigonometric identity. Now it's your turn to try. Tan x cos x is equivalent to which expression? Feel free to pause the video. The correct answer is A, sine of x. Recall that sine of x is equal to tan x times cos x as per the summary slide. Let's try again. 1 minus cos squared x is equivalent to which expression? Again, feel free to pause the video. The correct answer is C, sine squared x. Recall that sine squared x is equal to 1 minus cos squared x. We can take advantage of the quotient and Pythagorean identity to prove more complicated identities such as this one. This is done by constructing a table and placing the left side and right side of the equation in as follows. We can then look to see if we can make a substitution for a more simpler expression. In this case, we recognize that since positive cos squared x and sine squared x are present, and that they're equal to 1, we can switch the 1 in the sine squared x, realize that cos squared x plus sine squared x is equal to 1, and simplify as follows. Since the left side of the table is equal to the right side of the table, we have proven the trigonometric identity. Here are some practice problems you can work on. Feel free to pause the video, and the solutions are included in the uploaded PDF accompanying the lesson. Thank you.